I'm David Stringer, and this is R-2000, the Better Built House. We've been looking at some of the ways that construction practices differ in R-2000 houses. And one of the main differences is the emphasis that's put on air leakage control. So in this program, we're going to look in detail at some of the techniques that are involved in controlling air leakage in houses. While we're waiting for Oliver, here's a quick review of the basic principles involved in airflow in houses.
Air leakage in housing can be responsible for as much as 40% of the fuel bill of the average Canadian house. Not only does uncontrolled air leakage represent a burden on the homeowner's wallet, but it leads to uncomfortable drafts throughout the home. Finally, air leakage can lead to potentially damaging moisture problems as the air transports water vapor into the concealed wall and attic sections. The Better Built House will be constructed with a continuous air barrier to reduce both uncontrolled air leakage and the moisture associated with it.
Hi, David. Hi, Oliver. I understand we have a guest on today's program.
We do?
Yep, it's you, me, and Polly, right?
Well, polyethylene, right. We're going to be doing a lot of talking about polyethylene for sure. First thing I want to tell you about is the fact that because of its nature, it's got the characteristics of both an air barrier and a vapor barrier. Two mints in one, you know what I mean?
Yeah, in other words, moisture won't go through it either.
Exactly. As a result, you can install both an air barrier and vapor barrier using just one material. There are other ways to do this job. You can put in an air barrier and then supply a vapor barrier in other ways, and we're going to be looking at that in other shows.
But today we're sticking with poly as an air vapor barrier, right?
You got it.
Well, let's go have a look over there.
Okay.
Now, part of the concept of the continuous air vapor barrier, which is so easy and lovely to say, is astounding when you think about it. You're saying there are going to be no holes, no penetrations in this barrier around the entire house. As a matter of fact, we should be able to take the house, put it in the ocean, and sail it to Europe.
Insofar as possible, that's just exactly what we're saying. Wherever you have penetrations that go through it, they're going to have to be very carefully sealed. It's one great big sheet. But the fact of the matter is that it's very hard to handle one great big sheet of poly. So you have to go about looking at detailing that will enable you to use the largest sheets possible, but still be able to handle it.
And I suspect there's a reason why we're standing at this seam, huh?
You bet there is. What we've got here is a seam between two large sheets that's being made directly over a stud. You'll notice that the stapling, which is holding this in place really on a temporary basis, is made over this bead of caulking and directly on top of the solid backing.
Now, what's going to go on here? What goes on the front of it then?
Well, when you finish this room, if it has interior strapping, for example, in order to run electrical chases through it, you would probably be putting a batten down directly over this. Alternatively, if you were drywalling the building directly on the stud, the drywall would stick it tight. Can you just stick your finger in that for a minute?
Oh, sure.
It's real sticky, huh?
Yeah.
What we want to do is you're never going to get that off, incidentally.
Maybe on you after the show.
I hope not. The thing here is that's all over my truck, you know. The thing here is that this very gooey material remains flexible over time. So even though the stuff is squeezed in there really tight, we know that we've got a really nice airtight seal.
Now, any place the sheets get joined, it's over solid backing with this lovely caulking and then sandwiched down. How do you get this to go all the way around the house? What's the system? Like, how do you...
The first issue is pre-planning, and I think that's what we ought to go look at now. You really want to sit down with the blueprints and figure out how you're going to get it in.
No, I really want to sit down with a bar of soap and figure out how I'm going to get this off.
Good luck. Blueprints. That's the key to the whole issue. What you want to do is you want to ensure that you're doing all the planning up front. So what you're looking at here are interior partitions. You can see here. The areas where the floors are going to be meeting the walls, as in a detail, you want to make sure that in each case you've dealt with the air vapor barrier issue.
So you're basically planning where you need little strips of poly right at the blueprint stage before you ever start framing.
Right on. Depending on what kind of a system you're using, it'll either be poly or airtight drywall. However you're going to deal with that issue, you have to make sure that you're dealing with it through the headers where the floors sit on the walls or in the walls, and wherever interior partitions come up to outside walls to ensure vapor barrier continuity from one room to another.
What do you do about those kind of major penetrations like the electrical service, plumbing stack, that sort of thing?
You're always going to have them. You're going to have lawn lights. You're going to have hose bibs that go out to supply water to the outside. but you try to minimize them as much as possible. The electrical code requires that you have one electrical box every 12 feet in the wall, but you just try to avoid them wherever possible. Example, you've got a switch to control the lawn light. Maybe you can put it in an interior partition instead of in the outside wall.
So you want to avoid anything you'll have to deal with, right? Because any little penetration is going to have to be taken care of.
If you can keep it out, that's best.
Can we see some of that actually going in practice?
Sure. Let's take a look. Now we're going to get a chance to look at some of those tabs. Around the header and into this room. This tab is passing through this partition, and there's another tab up at the ceiling which passes from this room around the header and into the room above.
And those tabs will be joined to a piece of poly that's right here.
And that gives us our continuity. Some guys are leaving out interior non-load-bearing partitions and just running great big sheets in and framing the partitions later. But that's the issue. You've got to get these tabs in the right place while you're framing, or you're never going to get a continuity.
It's interesting, and it seems like such a simple thing to just throw a little tab of poly around the header when you're building the wall.
Couple of things to be careful of. It's very easy to violate the 1/3, 2/3 rule when you go around a header.
Oh, because that header is the outside of the building, and you're now moving the barrier to the outside, and you want to have some insulation beyond it.
So you want to make sure that you're going to have 2/3 of the insulation, R value of that segment of the building, on the outside of the poly.
How do you do it?
One thing to do is to withdraw the header from the outside, giving you more room to put insulation in there, and use a very high R value insulation. Alternatively, you could use the stuff you're standing on.
Oh, I thought that was paper wrapping.
Well, it is paper wrapping in a sense. It's called Tyvek. There are several companies that produce materials like it, and it's a breathing paper. It's an excellent air barrier, but it's not a vapor barrier. So if you have a circumstance like a cantilever, for example, where it's very difficult to ensure that you've got enough insulation on the outside of the barrier, you can use that stuff.
But it is best to design the problem out
wherever possible.
In the earliest stages. And you get a nice, tight, beautiful, continuous air barrier, and then you're going to saw big holes in it for the electrical outlets.
Yep, all over the place, and I want to show you how we do that.
So this is just a normal wall behind here, is that?
Completely conventional wall. In this case, 2x6. We've got an air vapor barrier on top of it, and the drywall goes directly over it. That creates problems wherever you have penetrations in the exterior wall. The best thing to do is to simply leave them out. But if you can't do that, and most plumbing and electrical codes, certainly electrical codes, require boxes every so many feet on the wall, you've really got to deal with the problem here. What this guy has done is to build a box out of plywood backing with wood around the sides so that he can lead the wire into the box through a very small hole and then caulk it. So the receptacle actually sits inside a box that's covered with vapor barrier.
And that was covered before it went in the wall, of course.
You got it. Now you can, if you want, put additional insulation into that box then to keep your R values really high, but you've got to be extremely careful not to violate the 1/3, 2/3 rule.
Oh, because you've moved the vapor barrier now further into the wall around the back of the box.
That's it.
But the best thing to do with penetrations is just try to design them out right from the start.
Wherever possible. However, you're going to wind up with hose bibs, you've got dryer vents, you've got all kinds of things that have to go through the wall. And where that happens, you always want to make sure that it goes through the wall as much as possible at 90 degrees, because that gives you the opportunity to make a very small hole and then caulk it and seal it really well. One alternative is to use neoprene.
And where does this thin board go?
Well, you take a piece of plywood and actually let it into the stud, because you can't have it in front, otherwise it becomes a bump and you can't get the drywall over it. So you let it in, and it gives you solid backing for the penetration.
And the neoprene is kind of your main thing for piping?
Yeah, you caulk that directly against the vapor barrier on a hard backing, and you wind up with a really good seal. We usually use them around plumbing stacks.
Oh, well, let me go see if I can find one.
Well, look upstairs. And here, David, you see that we're using exactly the same neoprene gasket in order to obtain a flexible seal at the plumbing stack. Over there, where the chimney passes through the air vapor barrier, we're putting in a sheet metal gasket in order to achieve the same thing, but of course we have to be concerned about fire safety.
Those are some pretty interesting techniques to me and useful to builders, I hope. The other day, Oliver and I toured a site where they're using a totally different approach to the idea of air vapor barriers. It's called the airtight drywall approach. So have a look at it. We're going for coffee.
All right.
Now, so far we've been talking about an air vapor barrier all as one sheet of poly. Now, there's something different about this airtight drywall approach.
Sure is. And it's based on the fact that you can separate those two functions. You can separate the vapor barrier from the air barrier. Let's take a look at what would happen if you very carefully gasketed all the various pieces in the building as you constructed the building and then relied on the drywall for your air barrier. Imagine, if you would, that this floor were the top of your foundation, that you had a good gasketing material and that you put your first plate down on that with absolutely no air leakage in between. Imagine that you then had a gasketing material that it would be possible for you to lay on top of that plate, and that this were the floor header assembly, which would sit on top of that. We'd use this tape again in here, and then you would wind up with the floor on top of that. We now have a header assembly through the building, which is more or less airtight. If you then have the bottom plate of the wall, which is going to sit on top of this, with a gasket underneath it, and you gasket the joint between the drywall on the interior of this and the plate itself, you can make the whole assembly pretty airtight.
No, that's interesting. You're airtight, but you're telling me, you're insinuating you're not vapor tight. What happens to the vapor barrier now?
Well, vapor diffusion is not the most important or significant way in which humidity gets into a wall. Air leakage is. You can deal with the vapor by just dealing with the surface area of the wall, because it's a function of surface area. If you cover 90% of the wall, for example, with poly, even though it's discontinuous, you've cut your vapor diffusion by 90%.
So I would just staple poly over the insulation like I've always been doing.
Exactly.
Now, what do you do about penetrations in the outside wall?
Well, for example, you'd use something like a gasket over areas where you're going to have electrical boxes sitting in behind the cover plates. Those things are manufactured for that very purpose, to stop air leakage. You'll still get a little, but it won't be very serious. And any place you have plumbing stacks, anything like that, you have to treat them in more or less the same way we've been seeing.
Okay, Oliver the perfectionist. All wood isn't necessarily so beautifully straight, and foundations are crooked. This seems a little fiddly. What are the advantages?
Well, you have to pay careful attention to the gasketing, without a doubt. But the primary advantage is that builders like not to disrupt the way in which they run their trades across the site. And one of the good things about this is that if you can get your framers accustomed to putting these gaskets in, you don't have to really deal with the whole air tightness issue until you get to the drywall.
So it's up to the individual builder?
Always.
Well, I guess airtight drywall was a totally new concept for me, but actually finding out what the plastic is, you see this all the time, but finding out that it can be a continuous air barrier was really interesting. Now, how do you decide which of those systems to use?
Like all the other decisions a builder has to make, it really depends on your crew, what you're building, market price, all that sort of thing. Many guys do both systems.
Well, how do the tradespeople react to, having new systems thrown at them?
I think the tradespeople are very much like you and me. The point is that if they understand the value and purpose in something, they're quite capable of doing it. If they don't, maybe you don't get the job.
Well, you're a good guy for the job, because you made me understand that having that continuous air barrier in the house is, I guess, is the key component to the better built home.
Are you looking for work?
Well, not yet. Anyway, what have you got for next week?
Well, next week we're going to be looking at the whole construction process from the ground up, so we'll be starting with foundations.
Ah. Well, that's great, because I actually like to see things from the very beginning. So join us next time on R-2000, the Better Built House. Think they're going to make us do that one again?
I'm sure they are.
Yeah, oh, my shoelace was untied.
Yeah,
the prop department didn't put any mud on that boot either.
No, and my mic is messed up.
Your pen's in the wrong side of your pocket.
Continuity.
Yeah. Well, let's just refer to the script. I guess we can throw this one out now.
Is that a cut, Si?
No. Yeah, so that kind of dialogue is great.
That kind of dialogue is great, he says. You added
So
that.
we are going to do it again.
2, 1, action.
Airtight drywall, I guess I'd have to put on my list of really new concepts. What's your... It wasn't that funny. It wasn't that funny. We're ready now.
This is television. Thank God Si is here.
Television, the part you don't see.